Equilateral triangular lamina of 25 mm sides lies with one of its edges on HP, such that the surface of the lamina inclined at 60 degrees. The edge on which it rests is inclined to VP at 60 degrees. Draw its projections. So first, whenever we want to solve this problem, first we have to identify the surface inclination with respect to HP. So whether it is starting from HP or it is starting from VP. To identify the problem whether it should start from HP or it should start from VP, then we have to look for the surface inclination. He says the surface is inclined to HP at 60 degrees. So obviously we have to start from HP. And if it has to start from HP, the surface inclination with respect to HP should be 0 degrees. So that means it should be parallel to HP. So here in this case, you can see the surface is parallel to HP. As we look from the front view, A dash, B dash, C dash are parallel to XY line or parallel to HP. So obviously we're going to get the true shape here, which is A, B and C now. Now when you look from the top view, we can see A, B, C all are in true length. So each side will going to be equal to 25 mm. So AB equals BC equals AC will be 25 mm. And AB is inclined to VP. Therefore, you are getting apparent length in VP. BC is inclined to VP. So we are getting again B dash C dash. This is an apparent length. A dash C dash is parallel to HP. So obviously you are going to getting the true length in HP. And also AC is perpendicular to VP. So that is the reason why you are getting a point in the VP. And A dash B dash is parallel to HP. So AB is in true length. And B dash C dash is parallel to HP. So BC is in true length. So the entire top surface, the entire line in the top surface or horizontal plane will be in true length. So that is the reason why this triangular lamina is in true shape in the top view. Now, this is what we have shown in the orthographic view, but he says with one of its edges on HP. So the edge which is resting on HP has to be perpendicular to VP, because in the front view, you will going to get a line, a point. So only with respect to that point we can rotate so that the edge will going to rest on HP. Now, when you look from the front view, A, B is near to the observer, so A dash and B dash is visible. And C is away from the observer, so C dash will be in bracket. So this AC is the side which is on the left side, which is A dash C dash. So this will be on the left side. And this side, this point will going to be the corner point. Now as he says, it is resting on one of the edges on HP. So it should rest on A dash C dash. Now we can see here in the second position, AC is resting on HP, such that the surface makes an angle of 60 degrees with respect to the HP. So when the surface becomes inclined at 60 degrees to HP, obviously that surface still perpendicular to VP. So that is the reason why you are getting a line in the front view in the second position. Now that is also quite evident in this orthographic view, wherein we are taking any convenient distance, you mark that point which is A dash C dash, which is parallel to HP. So obviously you are getting the true length in HP here. So that is why reason why we are shown this as the true length. So what is the true length? The length of this and the length of this true shape in the both are equal. So that means you have the length is 25 mm here. So here also it will going to be 25, and the surface is inclined to HP. So you are getting the apparent shape in the top view. But since it is perpendicular to VP, so you are getting a line in the front view. So since it is perpendicular, so that is the reason why we can see the inclination, the surface inclination with respect to HP. Now the edge on which it rests is inclined to VP at 60 degrees. Now the inclination what he has given is the true inclination here, because in the true inclination, the edge which is resting on HP. So the edge which rests on HP means it in the second position we can see here, A dash C dash which is on XY line, it is parallel to HP. So you are getting the true length here. So, but the inclination given is also true inclination. If it is an appears to be, then only you are going to get the apparent inclination. But here it is the edge on which it rests is inclined to VP at 60 degrees. So the edge which is the true length here, So the inclination is also true inclination. According to the projections of straight lines, on the true inclination line, we're going to get the true length. So we just rotate the second position top view by rotating at an angle of 60 degrees, and then write the corresponding front view. You will going to get the corresponding front view, that is A dash C dash is on XY line. So that is what, and this sketch and this sketch will going to be the same. So as we see from the front view, A and C, which will be on HP, so A dash C dash will be on XY line in the front view, and B is above HP, so B dash will be above HP now. So this is how you will be able to analyze this problem in 3 dimension and as well as in the orthographic view. How do I know that this problem is right? We can see that the edge which is resting on HP is A dash C dash, and that edge is inclined to VP at 60 degrees here, and the surface is inclined at 60 degrees to HP, and it is an equilateral triangle of 25 mm side. Since we are satisfying all the conditions given in the problem, and hence this problem will going to be the solution which can be analyzed. Now we will going to solve this problem in the sketchbook. So to do that, first we will going to draw the XY line and mark XY and VP and HP. As it says that a equilateral triangle lamina of 25 mm sides. So first you will going to draw a vertical line because the edge which is resting on HP has to be perpendicular to VP. So draw a 25 mm line and you mark this point as small a and small c, and then with A as center, by taking the compass, take a radius of 25 and draw an arc on this side. And similarly with respect to the point C as center, cut on the previously drawn arc so that you will going to get this point B. Then join A to B, B to C and C to A with a dark line. Then you draw a vertical projector from A and C to the XY line and draw a vertical projector from B to the XY line. And when you look from the front view, both A and B is near to the observer, so A dash and B dash is visible, and C is away from the observer, so C dash becomes invisible. Then join A dash and B dash with a dark line. So then we can identify this is a side. When you look from the top view, you can see AC is a side and B is a corner, so this becomes corner and this becomes this side. So then once you complete this, then you take any convenient distance from B dash to this second position front view and you mark any point, and you mark that point as A dash and C dash in bracket by using the protractor with respect to the XY line with A dash C dash as center. Measure an angle of 60 degrees and draw an inclined line. Then by using the compass with A dash and B, with A dash as center, take the distance of A dash B dash with A dash as center in the second position front view. Cut an arc on that 60 degree line and then mark this point as B dash, and then join A dash and B dash with a dark line. So then draw a vertical projector from A dash and C dash to the top view and draw a horizontal projector from A and also from C. Both will going to intersect at the respective points of A and C in the second position top view, and mark this point as A and C. Then draw a horizontal projector from B and draw a vertical projector from B dash. Both will going to intersect at this point and you mark the point as B. Then join A to B, B to C and C to A with a dark line. As we see, A dash B dash and B dash C dash are inclined to HP, so AB and BC will be in apparent length. A dash C dash is parallel to HP, therefore AC will be in true length. This is the reason why we have written this as the true length. So the edge on which it rests is inclined to VP at 60 degrees. As we know that it is the true inclination, and this AC is also in true length. So on true length, we are going to get the true inclination. So you rewrite the second position top view at an angle of 60 degrees. So to do that, first consider any point and draw a horizontal line. Then by using the protractor with that point as center with respect to the horizontal, measure an angle of 60 degrees and then draw an inclined line. Again with C as center, by transferring the position from the second position top view, take the second position top view C center. By using the compass, measure the distance of CA, and from C, the third position top view, cut an arc on that 60 degree line and you mark this point as A. Again with C as center in the second position top view, measure the distance from C to this point, and from C you transfer it down to this in the third position, and by using the protractor with this position as center with respect to AC, you measure an angle of 90 degree and draw a perpendicular line with respect to CA. Then again from the second position, this point as center with respect to B, measure the distance from this point to B by using the compass with C, and in the third position, this point as center, cut an arc on that perpendicular line and you mark the point as small b. Then join A to B, B to C and C to A with a dark line. So this is how you will be able to rewrite the third position top view from the second position top view. Then draw a horizontal projector from A dash and C dash and draw a vertical projector from A to the XY line and also from C to the XY line. And you mark this point as A dash and C dash. Similarly, draw a horizontal projector from B dash and draw a vertical projector from B. Both will going to intersect at this point and you mark this point as B dash. Then join A dash to B dash, B dash to C dash and C dash to A dash with a dark line. So this will going to be the third position front view, which will going to be the final solution. And you mark. So then how to identify that our problem is right? So even in the final position, you can see that one of the edges of the triangular lamina is resting on HP. The edge on which is resting on HP is inclined to VP at 60 degrees, and the surface of the lamina is inclined at 60 degrees, and it is resting on one of the sides on HP, and it is an equilateral triangle of 25 mm. So since we have satisfied all the given conditions of the problem, and hence this will be the final solution which has been written in the sketchbook.